So this will be my first recording of a series of recordings that I'm planning to do on Amazon Bedrock Flows, which is a service, a relatively new service within Amazon Bedrock, and it is used. It is like a low-code agent LLM chain builder. So it is a low-code approach to develop an agent or a prompt chain or a LLM chain, but based on my exploration so far, I did not consider it as an agent orchestrator because of its acyclic nature. This service resembles more like prompt flow or LLM chain in LangChain, but it is not like LangGraph, which is an agent orchestrator because agents can go back and forth using the LangGraph type of orchestrator, which is cyclic in nature. But the Amazon Bedrock Flows is also a very powerful concept, right? Where it allows to orchestrate, although in a cyclic manner, different components of a I'll say of a uh, rack pipeline. Doesn't need to be rack pipeline actually. It can be um, any a cyclic pipeline or a unidirectional pipeline where one language model or one Bedrock agent or more than one language model or more than one Bedrock agents can work together to provide or to output a response, right? There are two types of nodes that I have seen in Bedrock flows. One type of node controls the logic of the flow, and the other type of node handles the data in the flow. The logic control nodes are again of type there is an input node. You can have one power flow and you must start with it, and we'll see an example of all these things when I show you a demonstration. Output node, you can have multiple output nodes or you can have a single or multiple output nodes based on your use case. In the demonstration, we'll see multiple output nodes. Condition nodes. Condition node is where it acts as a router logic, and based on the condition in that node, the input can be changed to other nodes in the flow. The iterator and the collector node, I am yet to experiment, but the iterator node seems to be able to take an array of inputs, and for each input, it can create an output. Collector node looks to me like if there is an array of output, it can um, return that as a array. The data handling nodes are the prompt node, where you can define the prompt. You can either write the prompt within the flow, or you can have the prompt from the prompt management service of AWS Bedrock. And that is another very important service or a very useful service. The prompt management acts like a prompt registrar. And I'm planning to experiment with that also and share some of my findings later on. Then there is an agent node where you can add Bedrock agents in the flow. Knowledge base, when you add knowledge base in the flow, if there is a AWS or an Amazon KB created, Amazon Bedrock KB created, you can send a query to the knowledge base, get the information and pass to the next nodes. S3 storage, lets you integrate with AWS S3 if you want to store some data from the flow in S3. S3 retrieval node helps you to get any data from S3 in the flow. Lambda function, that's a very another beautiful feature that I found, right? If you want to add any programming logic in the flow, you can do it through Lambda function. Right? For example, if I have a retrieval logic running on Kubernetes service, right, I can actually call that retrieval logic using Lambda function. And the Lex node lets you call an Amazon Lex bot to process an utterance using natural language processing. So you can identify an intent using the Lex node. Let's now go to the demonstration and see how we can create flows. So I have already created a flow. We'll create this flow again from the scratch. And what this flow does, let me actually show the flow to you. Let me edit it, right? So what I have created is, so this is the input node. As I mentioned, the input node is one per flow, and you must have input node, right? This is what takes the input, and it is connected to a prompt node, right? What I'm doing here is, based on the question, right, whatever the question I'm asking, this prompt node will take the question and extract the subject of the question, basically whether it's a maths related question or a physics related question. So this prompt takes the question, categorizes the question into a maths question or a physics question, and output of this will be either maths or physics. And it is supported by this model, Claude V 2.1 model, right? After that, this prompt connects with conditional node. What the conditional node does is, the name of the conditional node is condition input. And if the condition input is physics, that means if it got the output or the input to this is physics, right? Then it connects to the physics response prompt. So let me see which prompt is this, right? This is physics, right? So I incorrectly said maths response. It should be physics response. While we create it from the scratch, we'll correct it, right? It will connect to the physics response if the condition is physics. If it is maths, it will connect to the maths response. The physics response answers physics questions provided below. If you see, there are two connections to the physics section prompt. One is from the conditional node, which, like if it is a physics, it triggers the prompt, but the prompt, the actual input, it takes from the input, which is the question, right? And the output of the question goes to the flow output, right? And the output of the maths question goes to the maths flow output. So this is the final response, right? This is what we'll build from the scratch now. Let's see how to build it. Let me go to flows, create a new flow. Let us name it example 02. This flow takes in a question, categorizes it into maths or physics, it routes it to the appropriate prompt based on the classification and gets a response, right? For now, I'll create and use a new service role for this, and I'll go and hit the create button. Now I am in the editor, flow editor screen. I'll minimize this and let's start creating the flow, right? Let me first delete this, right? So the input flow, it will be of type string, right? I need a prompt node, right? So I will bring a prompt node here. I'll name it the router node. Now I can either use a prompt from the prompt management, as I was mentioning previously. We'll look at prompt management in another recording, subsequent recording. But for now, we'll define the prompt in the node itself. Now, before I define, I need to select what model, language model this prompt will use. I will use Anthropic Claude v2.1 on demand, apply, right? This is again a beautiful concept. If I have AWS guardrails, I can actually attach a guardrail also to it. Again, something that we'll see in subsequent recordings. Here I will give the prompt. I'll say extract the subject of the question. The subject of the question can be one of maths or physics. Extract output only the extracted subject. Do not add anything else in your response. Okay. So this is the prompt. Inference configuration, I don't want it to be creative. So temperature, I'll put it to 0. Right? And maximum output 300 is fine for me. Right? I don't have any input. And I'll now connect this. Okay, so one thing I need to do, okay, so the thing that I did not do is extract the subject from the provided question. Right? Now I have to put a placeholder for the question. Placeholders are done with the double brackets, curly brackets. I'll say question. As soon as I say question, you'll see here I got this connector. I will connect this to the prompt node now. Next, I will bring in a conditional node, right? So let me bring in the conditional node and I will name it condition input, right? Actually, the name is here. So node name I can say I can say router condition node. Right. So name is condition input, right? Then what is the condition, right? The first condition name is, let's say, maths, and I'll say answer the provide an answer to the maths. Oh, sorry, no, this is the condition, right? So the condition should be condition input, right? So condition, so basically condition input equal to maths, right? This is the condition. I'll add one more condition, which is physics condition. And here the condition input will be physics, right? So now you'll see I have one connector for the maths, one connector for physics, and the third connector is like if all the conditions are false, then this is a connector. We'll not use it, right? So now from here, I need to connect to the condition prompt, right? So from here, this is the model uh, output, right? So I'll have to, this is right. And this is okay, I need to bring in a prompt node now, right? Because one prompt node I need for maths, one prompt node I need for physics, one prompt node to answer the maths question, one prompt node to answer the physics question. Let me bring that node, prompt node. This one will name as maths prompt, right? Again, I'll define in the node this prompt. I'll say answer the maths question, right? And the question will be yes, right? So now, okay, I need to select model call load. Okay, no guardrail. Inference conditions, I'll say nothing. So from here, I will send it to this. So this is the condition, right? If this condition, it goes to this prompt node, but this prompt node needs to get the input from my input question. So it will come from here, right? So I need to connect this, right? And the output of this, I'll send it to this flow output node. This one I'll say maths response, and I will connect this to the output. So the output gets rendered by this flow output, right? So we have taken care of the maths part, right? Next, let me bring in another prompt node which will handle the physics question. So we'll say physics prompt, define in the node. Here also I will use anthropic 0.1, apply, no guardrails for now, answer the physics question provided below, and the question, right? The same thing with this. So this physics, if it is physics, it goes to this prompt node, but the input comes from here, right? And I need a output node so that it can render it. So I'll bring an output node and name it physics response, and connect this to physics response. Let me save it and hope that nothing goes wrong. Yep, successfully saved, right? So my flow is created now. I'll save and exit out of it. Let me see if where the flow is now. So let me publish the version now. So this is, you see, if it is not prepared until I create it, it will get prepared. So I'll say publish version 1 selected. The version 1 has been selected, right? Now I can create an alias for this version, right? So that tomorrow if I create another version, I can attach the alias to that version, right? So let me create a alias. I'll say teacher, say maths physics teacher. I'll not put any description for now. I'll use an existing version, the version that I have created, which is version 1, right? And I'll create the alias. Now let us test it out, right? So let me click on the alias, view it in the flow builder, and let us ask some question. What is Pythagoras theorem? Right? This is a maths question, so it should be taken care of the maths prompt. Let's see if it does. It shows physics response, but actually when it is done, it will say maths response, right? So it went to the maths response, right? If I show the trace, it actually says how it actually flowed through, right? So what is Pythagoras theorem? From there it went to the router, right? Router output node. It says it is a maths question. The condition node maths question, router condition, right? It applied the condition. It went to the maths prompt, created the output, right? The maths response, and it went to the final flow output, right? So this is the this is what has this is how we can trace the call as well. It's a beautiful feature again, right? So let us ask another question. What is refraction, which is a physics question? Run. Let's see now. Yeah, let's say the trace, flow input, what is refraction, the router, it went to the router, output is physics, the router condition satisfied, right? Then it went to the physics prompt, and the output is given to the finally the physics response out the flow node, right? So this is how now I can actually, so whatever I have done in the console, it can be done programmatically also using the Bedrock client. And I'll have a subsequent recording to show how we can programmatically create and access this flow. In fact, after this flow is published, right, I can externally call it through invoke flow as well. Those I'll do subsequent recordings to programmatically access these flows. That's all I wanted to show as part of this recording, and I will come back with the next recording shortly. Bye-bye.